So today let's solve 102 of LeetCode binary tree level order traversal. Of course, to solve this question you should have a very good understanding of what is a binary tree, how does a level order traversal work, and also you will need to know how does a queue work, because you will need a queue data structure for the level order traversal. So let's see what they want from you. It's not actually that like basically what they want is that you will go through the every level of the tree. For example, here is the first level, right? So first level we only have the value 3, so 3 is here, 3 is a separate array. And then we have the second level where we have 9 and 20, so we have 9 and 20 on a separate array. And then we go to the third level, and in the third level we have 15 and 9, 15 and 7, so we have 15 and 7 in a separate array, and then the whole thing is inside of an array, and this is what we have to return as the answer. So how can we do this? It's actually very simple. We just need a queue, use the queue data structure. So here is the queue. What we will do is that first we will just we'll basically go through each level. We'll add the node of that level on the queue, and since there's something that we have to do, since it says that you have to make a separate vector of the value of a separate level. In each level you will have to make a separate array or separate vector. Since you have to do that, you have to use a for loop in each level. Let me explain you how. You go through first level, you add 3 in your queue, right? Then you will say that you will basically run a for loop according to the size of your queue. So in the first now we just the size of our queue is only 1 because we have one node in here. So it will go through, the loop will go 1, and for 3 it will basically we will find the left subtree of 3, which is 9 in this case, and then we will find the right subtree of 3, which is 20 in this case. So it's just going to add 9 and 20 in the queue. Here we have 9. I know it doesn't look like 9, but it's 9. Okay, and then we have 20, and then of course like we'll just pop the 3 from here. Then we have 9 and 20. So now we have 9 and 20. Then we'll just go through another loop, and this time the size of the queue is 2, right? So the loop will go twice. For first time for 9, so 9 doesn't have any left or right subtree, so there's nothing going to happen to it, and just 9 is going to get popped out. And then we have 20. For 20 we have in left we have 15, in right we had 7, so it is going to add 15 and 7, and the 20 is going to get popped out. And since we are using a for loop for a separate level, it will going to make a vector of them. Okay, I guess it makes sense, and if you I hope if you see the code, it's going to become much more clearer. So let's just go to the code. Okay, first of all, since we have to return a vector of integer, so let's just take that first. Oh my lord, what am I writing? Sorry about that. Vector of integer. This is what we will return as answer. Let's just get rid of the edge case, which is if the root is empty, right? If there is no root, then just simply return answer. So we got rid of the edge case first. Okay, then of course we'll need a queue, so let's just call the stl queue, and the queue will take the nodes as input in the queue, so keep that in mind. We are not going to take integer as queue. Okay, and then we have to just push the head, push the root of the tree in the queue. Then of course we will just go through a while loop that we need to go through in any level order traversal. So it will run if the queue is not empty. Okay, So after that, like I said, we'll need the size of the queue. So let's take int size, queue dot size. Oh my, it's bugging me. Wait, sorry about that. Yeah, queue dot size. Now that we have taken queue dot size, we'll have to run the for loop. Okay, for int. Okay, what am I writing? I is less than size I plus plus. So tree node, oh my lord, not nose node, parent, let's just call it p, and we'll take the front of the queue for here, and then we'll just pop the queue, top of the queue, and then just we'll just have to see if p have left or right subtree or not. If okay, if we have left, then just yeah, queue dot push left, and then if we have right of the p, queue dot okay, queue dot push the okay, right of the tree. And of course we'll just okay, now something is that we'll need a vector, right? This is the vector, like in each level we'll have a separate vector, right? Because of that we are taking this vector, and this is not going to be a vector of tree node, this is going to be just integer, vector of integer. Let's just call it level, and now let's just, yes, we have to push in this level, push back the value of p, right? So when we come outside of the loop, what we'll have to do is we have to push that level in the answer. So answer dot push back level. Let's just make the level empty, clear, see, clear, yeah. Let's just clear the level every time we go out of the road, and then we just have to return the answer, and that's it, and that should work fine. Let's just see. Yeah, the way you can see that it has worked fine. Let's just submit it. Yeah, so that's it, and it has O of n time complexity, of course, because it just goes through the whole tree in a level order traversal. So I hope it makes sense, and I'll close it for now.